Okay, number one, negative x squared plus 15x minus 50 is greater than 0. All right, the first thing we want to do is set it equal to 0, regardless of the sign. All right, the reason I'm setting it equal to 0 is because we want to figure out the roots. That's the goal. Because it's equal to 0, we can factor this. The first thing I notice is that this is the leading coefficient is negative. I want this to be positive. So if I multiply everything by negative 1, it's going to change the signs. And this, I feel this is easier. This will be easier to manage, I think. Right? Because just because we're multiplying it by 1, by negative 1, we're not changing the value. We're not changing the roots, right? Because this is negative. If those are the roots, when I multiply by a negative, the roots don't change. The orientation of the parabola changes, but the roots don't change. And it makes it a lot, I mean, in my mind, it's simpler to factor when a is 1. It's my opinion. Okay, multiples of 50 that add up to negative 15. So 1 and 50, 2 and 25, 3, 4, 5, and 10. I think that's it. So 5 times 10 is 50, but I need this to be negative. So both of them, both, right, negative and a negative make a positive, and then these add up to negative 15. So my roots are going to be x minus 5, x x plus 10, no, x minus 10, because it's negative. The numbers drop right in. And this is equal to 0. That means the roots are going to be, right, set each of these equal to 0. So it's basically the opposite sign. So x equals 5, positive 5, and x equals positive 10. Okay, we draw our number line. I have two roots, right? This is infinity, negative infinity. 5 is to the left, 10 is to the right. Okay, so we split this into 3 intervals. We're going to test a number in one of these intervals, on one of these intervals. I like testing 0, right? 0 would be out here to the left. So I plug in 0 into the original, and I see that this is 0, this is going to be 0. So negative 50 is greater than 0. And I ask myself, is this true or false? Right, this is a false statement. This is a false statement. So since 0 was on this interval, and it's a false statement, that means we shade in between the roots. Right? We have our roots open circles because of the greater than sign. So anything in here should satisfy this equation. Number 2. Two x squared minus 6x minus 9 is greater than or equal to 11. All right, first thing I want to do is subtract 11 from both sides. I want everything to be to the left, and I want this thing to be greater than or equal to 0. Right? 0 needs to be on the right-hand side. So it's going to be 2x squared minus 6x minus 9 minus 11. So negative 20 greater than or equal to 0. All right, I'm going to consider when it is equal to 0, because this will tell me where the roots are going to be. Our first thing that jumps out at me is that these are all even numbers, so I can factor out a 2. So if I divide everything by 2, right, 0 divided by 2 is just 0. This is going to be x squared minus 3x minus 10 is equal to 0. Okay. Multiples of 10 that add up to negative 3. Negative 10 that add up to negative 3. So negative 10. We have 1 and 10, 2 and 5. I can make it 3 out of 2 and 5. So one of them has to be negative, right, because this is negative. This tells me that the big one must be negative, which means x plus 2, x minus 5 equals 0. So the roots are going to be opposite of what's in here, right? Because if I set each of these equal to 0, x equals negative 2, x equals positive 5. So these are the roots. Now, once I have my roots, get my number line. Again, infinity, negative infinity. Negative 2 and 5. Negative 2 is going to be to the left. 5 is going to be to the right. Okay, so I pick a number somewhere on these intervals. I personally like to choose 0. 0 is on the center, the middle interval. So I'm going to plug 0 into the OG equation. If it's true, I shade in the middle. If it's false, I'm going to shade outside. So this is going to be greater than or equal. So let's put my circles. They're closed because it's or equals. Now we plug in 0. 0, 0. And we ask ourselves, is negative 9 greater than 11? No, it's not. It's not. It's false. Negative 9 is smaller than. So we shade outside. All right, number 3. X squared plus 6x plus 3 greater than 0. Everything is already to the left. 0 is on the right. Is this factorable? I don't believe it is. Not from just looking at it, at least. So I'm not going to waste any more time. Let's just push it through the quadratic equation. So A, B, and C. Quadratic equation says negative b, so minus 6, plus or minus b squared, so 6 squared is 36, minus 4ac, so 1 times 3. All over 2a. So 2 times 1 is just 2. Okay, let's simplify the discriminant. So 36 minus 4 times 3 is 12. I'm not even worried about the 1. So 36 minus 12 is 24. Plus or minus root 24. All over 2. I'm going to simplify what's inside of here. So it's going to be 4, 6. Right? I can pull out a 2. So negative 6 plus or minus 2 root 6 all over 2. So this is going to be, they're all even. So I can factor out a 2 here, here, and here. So 2 goes into 2 once, 2 goes into 6 3 times, and this 2 will go away. So I'm going to get 2 answers. Negative 3 plus root 6 and or negative 3 minus root 6. So let's think about what this is saying. On a number line, from infinity to negative infinity, I'm going to place these 2 numbers. Which one's to the left and which one's to the right? That's the question. So this is going to be, so square root of 6. Okay, so -3 plus root 6 is approximately -0.55. And -3 minus root 6 is going to be -545. Okay, so when we order these here, this one will be to the left. So -3 plus root 6, -3 minus root 6 will be to the right. So this value is to the left. This value is going to be to the right. And just in case you were wondering, root 6 is about 2.45. Okay, so let's test a number on one of these intervals. I personally like to test 0. Where does 0 fall? So both of these are negative. So 0 is going to be out here on this interval. If 0 is true, when I plug it into the original, we're going to shade the outside. If 0 is false, we're going to shade the inside interval. Okay, so 0, 0. 3 is greater than 0. True statement. So we shade here and here. It's greater than, so we have open circles, not colored in. And they're the intervals that satisfy this inequality. All right, number 4. 4x squared is less than 25. So let's go ahead and subtract 25 from both sides. So it's going to be 4x squared minus 25 is less than 0. All right, right away I'm noticing that this is a difference of squares, difference of perfect squares. Right, 4x squared minus 25. This can be rewritten. Right, 4 is really 2 squared, so 2x squared minus 25, which is 5 squared. And we're considering when this is equal to 0, because we want to know the roots. We can rewrite this as 2x minus 5 times 2x plus 5, which equals 0. We set each of these equal to 0, and x is going to be, so plus 5 divided by 2, so positive 5 halves, and x is going to be minus 5 divided by 2, so negative 5 halves. Okay, let's go to our number line. Once we find our roots, I have negative 5 halves, positive 5 halves. We want to test the interval. 0 is going to be on the center interval, middle interval. So I plug in 0. Is 0 less than 25? Yes, it is. So that means it's a true statement. So we shade inside. Our circles are going to be open since it's strictly less than. Number 5. Okay, 4x squared is greater than 25. Okay, it's basically like the last problem, just the sign is flipped. So let's use the work from the last problem. What was it? X is equal to 5 halves. X is equal to negative 5 halves. So on my number line, we have negative 5 halves, positive 5 halves. Okay, let's test 0, which is on the center interval. So when I push 0 through, is 0 greater than 25? It's not. So it's a false statement. That means I have to shade out here. Again, with open circles because of strictly greater than. Number 6, 3x squared minus 13x greater than 10. First thing I want to do, subtract 10 from both sides. So 3x squared minus 13x minus 10 is equal to 0. So we can find the roots. Can't factor anything out. Okay, I don't want to spend too much time thinking, so I'll just go straight to the quadratic equation. Quadratic formula, rather. So A, B, and C. So negative B, in this case, B is negative 13, plus or minus square root of B squared, so 169, minus 4 times A times C. So 4 times A, which is 3, times C, which is negative 10. All over 2A. 2 times 3 is 6. Okay. This is going to be 13 plus or minus. So 169. This negative and that negative make a positive. And then this is going to be 4 times 3 is 12. Times 10 is 120. So 169 minus 120. Is that 49? Right, if I add 120 to this, I get 169. And that's actually very convenient. All over 6. Okay, square root of 49 is just 7. So my two answers are going to be 13 plus 7 divided by 6. Right, this is just 7. So 13 plus 7 is 20 divided by 6. So 20 divided by 6, which is basically 10 thirds. Right, 10 over 3. So this is one of my roots. Another root is going to be 13 minus 7. So 13 take away 7, which is 6. 13 minus 7 is 6. And over 6, so 6 over 6, which is basically 1, which is 1. So my two roots are 10 thirds and 1. So when we go to the number line, place them in order, right? 10 thirds, this is going to be about, well, it's bigger than 1, so it's going to be to the right of 1. Right, I'm comparing 10 thirds to 1. So it's like, which one's bigger? Well, I know that 3 over 3 would be 1. So this is definitely bigger than that, so it's going to be to the right. 0 falls on this first interval. So if I test 0 here into the OG equation, let's see what happens. 0, 0. Is 0 greater than 10? Nah, it's not. So that means, since it's strictly greater than, we have open circles. Since this is not true, right, 0 is not greater than 10, this is false. So that means I need a shade in here, in between, opposite of where the number is located. All right, number 7. 3x squared plus 1 is less than 15x. Okay, I'm going to subtract 15x from both sides. I'm going to rewrite things in the terms in descending order. So 3x squared minus 15x plus 1 is, well, it's less than 0, but let's look at when it's equal to 0, because that's where the roots live. Okay, I'm looking at it. Nothing's coming out of me. Can't factor it. Slide and divide method. That won't work. So let's just do the quadratic formula. Okay, this is going to be minus negative 15 plus or minus 15 squared. It's at 225. minus 4ac. So 3 times 1 all over 2a. 2 times 3 is 6. Okay. This is going to be 15 plus or minus. All right, 225 minus 12. Right, because 4 times 3 is 12. It's going to be 215 minus 2. 213. Right, if I add 12 to this, I should get that, and I do. Okay. I don't know if 213 is a prime number. No, it's not. It's divisible by 3, right? Because all of the digits add up to 6. So this is definitely divisible by 3. So 3 goes into 21 7 times with 1 left over. Okay, 71, for sure, that's a prime number. I can't do anything else. So can't be simplified. Right, 21, 7, 1. Nowhere on the times table is 71. Other than, 1 times 71. Okay, so we'll leave it like that. All right, I have 2 numbers here. So 15 plus root 213 divided by 6, and 15 minus root 213 divided by 6. All right, let's figure out an approximation so we can go to our number line and plot these roots. Okay, so the positive version is going to be approximately 4.9. The negative version is going to be approximately 0.0868. All right, so if we order these on the number line, this one's going to be to the left. So 15 minus root 213 over 6. This one's going to be to the right. So 15 plus 213 over 6. Okay. So 0, where does 0 fall? That's the question. Well, this is 0.06. 0 is barely to the left of this. Nevertheless, it's still in this interval. So if we plug in 0 into the original, what are we going to get? 0, 0. Is 0 greater than 1? Nah, it's not. So it's false. That means I don't shade here. I have to shade here. Strictly less than, so the circles are open. So there it is. All right, number 8. 4x squared plus 11x plus 3 greater than or equal to negative 3. So first thing I'm going to do is add 3 to both sides. So 4x squared plus 11x plus 3 plus 3 is 6 greater than or equal to 0. Now I want to figure out the roots, so we consider when does it equal 0. I'm not going to think about factoring it. Let's just push it through the quadratic formula. So this is going to be A, B, C. So negative 11 plus or minus square root B squared, so 121, minus 4 times A times C. So 4 times 4 times 6, all over 2a. So 2 times 4, which is 8. Okay, let's look at the discriminant. So 4 times 4 is 16. Actually, let's do it this way. 4 times 6 is 24. 24 times 4. Well, 25 times 4 is 100. Minus 4 would be 96. So 121 minus 96. Actually, be 21 and 4. So 25. 25. Negative 11 plus or minus square root of 25, which is 5, all over 8. Okay, here are my two answers, roots rather. Negative 11 plus 5, that's going to be negative 6 over 8, which is basically negative 3/4. Positive version, or correction, negative version will be negative 11 minus 5, negative 16 over 8, and how nice is that? Negative 2. So my two roots are negative 3/4, negative 2. Let's go to a number line. So negative 3/4 and negative 2. Well, negative 2 is bigger than 3/4, so it's going to be further left. So negative 2, negative 3/4. Okay, 0 is on this interval. They're going to be closed circles, right, because it's greater than or equals. And let's test 0. Let's test 0. So we got 0, 0. 3 is greater than or equal to negative 3. I agree. That's a true statement. So since it's true, the interval that 0 lies on is shaded, and so is this one. All right, number 9. Negative x squared minus 2x minus 1 is greater than 2. First thing I'm going to do is subtract 2. So negative x squared minus 2x minus 3 is equal to 0. These are the roots I want to find. It's negative, so I'm going to multiply everything by negative 1. Basically, it's going to change the sign of all of these. All right, so multiples of 3 that add up to 2. 1 times 3? Close. So nothing, right? At least nothing that I can think of. So straight to the quadratic formula. Negative b plus or minus b squared. So 2 squared is 4. Minus 4a, which is 1, times 3. All over 2 times a, which in this case is just 2. Okay, we're about to hit a complex number for the first time in this homework. So this is going to be 4 minus 12. 4 minus 12, which is negative 8. So negative 2 plus or minus negative 8 all over 2. Okay, negative inside the square root, that's going to come out as I. And 8, I can factor 8 into 2 times 4 and then pull out a 2. So this is going to be negative 2 plus or minus 2 root 2 I all over 2. The 2's are going to cancel, right, because there's an even number everywhere, top and bottom, both terms on top, one term on bottom. So my two roots are going to be negative 1 plus root 2 I and negative 1 minus root 2 I. All right, let's go to the number line. So my number line is from infinity to negative infinity, or negative infinity to infinity rather. So this is a real number line. Where on the real number line is negative 1 plus root 2i? That's the question. Well, fact of the matter is, it's not on the number line, right? This is a complex number. Complex numbers don't live on the real number line. So this is just my interval, right? This is the interval that I'm going to use. This is the interval that I have to use. So let's pick a number somewhere on this interval, right? Because a complex number, anytime you run into a complex number, you just use the real number line. Choose a number on the real number line. I'm going to choose 0, right? From negative infinity to infinity. Out of all the numbers in the world, I'm choosing 0. So I plug 0 in, and I get that negative 1 is greater than 2. Is that true? Is negative 1 greater than 2? No, it's not. It's not true. So what that means is, since 0 is on the interval, and 0 makes this false, no matter what number I choose, it'll still be false. So the answer is what interval, right? What interval satisfies this? Well, that interval is called the empty set, right? In other words, this is a fancy word for no solution, right? There's no real number. There's no real number. So we call it the empty set. All right, number 10. Negative 3x squared plus 4x minus 5 is less than or equal to 2. I'm going to subtract 2. I'm going to get negative 3x squared plus 4x minus 7 is equal to 0. All right, these are getting uglier. They're getting uglier. Quadratic formula. A, B, C. So negative b plus or minus b squared. So 4 squared is 16 minus 4a, which is negative 3, c, negative 7. All over 2a. So 2 times negative 3, negative 6. Okay. Let's look at the discriminant. So we have negative times a negative, it's positive, times a negative would be a negative. So this is going to be 16 minus 4 times 3 times 7. Okay, 7 times 3 is 21. 21 times 4, 2, 4, 6, 8. 1, 2, 3, 4. 84. So 16 minus 84. This is going to be 4, 6. Who's this? 8, 6. Okay, so negative 68. Negative 68 is inside here. That's what this is saying, right? Because I know it's 16 minus 84. I did 84 minus 16, but it's negative 68. So negative 4 plus or minus root negative 68 all over negative 6. We're going to factor 68. Taking into consideration that negative is going to come out as I at some point. So this is going to be 2 times 34, 2 times 17, and I can pull out a 2. Okay, my two roots are going to be 4 plus or minus, pull out a 2, root 17, I, all over negative 6. These cancel, so I'm going to get negative, what is this? This is going to be 2 goes into 6, 3, 2 goes into 4 twice, once. So this is going to be negative 2 plus or minus root 17i all over 3. I'm not even going to think about what this actual value is, right? It's a complex number. If you go to the number line, the real number line, negative infinity to infinity, test 0, which is on the interval of negative infinity to infinity. Plug in 0, we get negative 5 is less than 2, less than or equal to 2. Yeah, it's true. So no matter what number I pick, this will still be true. So the interval would be all real numbers, right? Negative infinity to infinity. No matter what number I pick, it will satisfy this. All right, number 11. Path of a soccer ball kicked from the ground can be modeled by y equals negative 0.0540 x squared 1.43 x, where x is the horizontal distance in feet from where the ball was kicked, and y is corresponding to the height. The soccer goal is 8 feet high. Write and solve an inequality to find at what values of x the ball is low enough to go into the goal. Okay, so what's happening is we got a soccer ball sitting on the ground, right? The soccer ball's on the ground. It gets kicked. We have a goal. It's horrible. All right, there's my square goal. I don't play soccer, so right, and then it's netted. I'm pretty sure there's nets all on the side to catch it. Okay, we want to know at what height is the ball low enough to go into the goal. Right, if they're this distance, the ball will go in, and obviously if they get closer, the ball will still go in. Okay, so let's look at it let's consider it this way. It's less than 8 feet, right? It needs to be less than 8, right? Anything below 8 feet will go in. Okay. I'm going to add 8 to both sides. So this is going to be negative 0.054 x squared plus 1.43 x plus 8 is equal to 0. All right, it's definitely quadratic formula stuff. So it's going to be A, B, C. So I'm going to get negative 1.43 plus or minus the square root, that number squared, 1.43 minus 4 times A, negative 0.054 times C, 8. Almost messed up. I have to subtract 8 from both sides. I caught it this time. It's the last problem, so it always happens on the last problem. All over 2 times A. So 2 times negative 0.054. All right, so the positive version is going to be roughly, well, it's approximately 8. So 8, and the negative version, approximately 18. Those are bad. So approximately. So 8 and 18. All right, 8 and 18. So if we pick a number, left or right, or in the center, again, I like 0. That's just me. So if I go back to the original equation, if I plug in 0, 0, is 0 less than 8? Yeah, it is less than 8. So it's true. So that means we shade left and we shade right. It's an open circle because it's strictly less than. So if we kind of interpret what this is saying, write and solve an inequality to find at what values of x, right? Meaning x is the horizontal distance. So if I'm closer, right, this is saying Right, this is a distance. You can't be less than 0. You can't have negative distance. So if I'm anywhere from, if I'm right up on the goal, or the kicker is right up on the goal, 0 to 8 feet, if they're within 8 feet, or if they're greater than, what is this, 18 feet, so anything greater than 18 feet and closer than 8 feet, that kick, this specific kicker's kick, will, or soccer player's kick, will make the goal. It's kind of interesting. All right, if you found this video useful, be sure to give it a thumbs up, subscribe, comment, let me know what you think.